Hello everyone and welcome back to another video. Today we're going to talk about solving absolute value equations both graphically and algebraically. If you recall from Math 10, what we used to do was we had to solve a system of linear equations, meaning that if we had a graph that looked just like this, and let's say we have one equation that looked like that, and let's maybe draw one with a negative slope, and we draw one that kind of looks like this. In order to solve this graphically, we would be looking for the intersecting point between those two lines, meaning we'd look for some sort of x, y ordered pair. Nothing's going to change when it comes to solving absolute value equations graphically. All we're going to do in this case is we're going to make the left side of our equation equal to y1 and the right side of our equation equal to y2. What that's going to look like on a Casio calculator, let's go ahead and do that. So on your graphing screen, we're going to hit option, we're going to hit number, go to absolute value right here at F1, and then we're going to use our brackets. We'll have 2x plus 4, and then for y2, we're just going to put in an 8. So I'm going to hit draw first, and we'll see that we end up with something that looks like that. It does not look anything like the example in the notes. So what we need to adjust is the windows. So I'm going to hit F3 here for our windows, and I'm going to hit standard. So that's going to change our window settings to a default. Again, if you don't remember our default or standard window settings, we are looking at our X minimum going from -10 to +10 with a scale of 1. And then for Y, it's going to be the exact same thing. Maybe I'll do it over here on the right-hand side. So -10, 10, and 1. And then for your Y window range for the standard settings, it's going to be going from -10 to +10 and have a scale of 1 as well. So going back here, we can see that we have -10, +10, scale of 1, and same thing as we scroll down for our Y values. So once we do that, let's hit exit. Let's go back and draw. And we can see that we have our two functions here. We've got our absolute value function, and then we have our y is equal to 8 sitting right there. So on a Casio calculator, all I need to do is hit G-solve, so F5 in our case, and we're going to look for the intersect. So again, F5, and we can see that our intersecting point here on the left-hand side, I know it's a little bit tough to see. It's going to be here at -6, 8. So let's go ahead and fill that in. So -6, 8 is our first. Maybe I'll do this on the side. So -6, 8 is my first intersection right there. And then for my second intersecting point, I'm just going to hit right. And we can see that we have 2, 8 as our second point. So 2, 8 is our second point. So we can go ahead and state our solution here. So our solutions are x is equal to -6 and x is equal to +2. So basically what we're trying to say here is that if I plug in -6 into my equation, we get a value of 8 on both the left and the right hand sides. And if I were to plug in 2 for x, then I should get 8 equals to 8. Now looking at the TI calculator, what we're going to do is I'm going to hit math. I'm going to scroll over to number, and we'll see that we're at our absolute value function right there. And we'll type in 2x plus 4 into y1. And then for y2, I'm going to type in 8. And I'm going to hit graph. And here, we'll see it kind of graph slowly here. And for this example, we don't need to change our window settings. We already have them on the standard settings. And we're going to hit second trace intersect, like it says here. So second trace intersect. And we're going to scroll down to option number 5. Oh, overshot a little bit. Let's try that again. Let's just hit number 5 to go to intersect. And for our first curve, let's find the one on the left first. So I'm going to scroll all the way over. You can hear my mouse furiously clicking in the background here. I'm going to go all the way over to the left, get close to that first intersection. Second curve, as long as, again, we're close to this left-hand side intersection, press enter, enter again, and we get an intersecting point of -6, 8. So you can see we get the exact same intersecting point And if I were to do the same thing, second trace, let's go to intersect. Now let's scroll over to the right-hand side. And we're going to hit enter. And then hit enter again because we're close. And then enter. And we see that we have an intersection of 2, 8. So depending on which calculator you use, those are two different methods to solve it graphically. Now, of course, if you aren't given the graph, we would have to graph these functions accurately. So just make sure that you sketch them as accurately as possible, and use a straight edge or a ruler if possible. In our previous example, you can see that we had two solutions, and now in this one, we only have one solution. So once again, looking at our graph here, we see that our answer should be 1, 2. So I'm just going to go ahead and write that down first, and then we're going to confirm that with our graphing calculators. So our solution, just by looking at this graph, should be 1, 2. But again, we don't want to trust our eyes too much. So our solution is x is equal to 1. So the solution is at 1, 2. So x is equal to 1. So for our examples here, let's start off again with our Casio. I'm going to go back into our functions here. Let's clear everything. Let's get rid of that. And we're going to get rid of this. And we're going to hit option, number, absolute value. And we get 3 minus x on the left-hand side. And then on the right-hand side, we get 3x minus 1. So I'm going to go ahead and draw this. And we see that we do indeed only have one intersecting point. Hit G solve, intersect, and we can verify that our solution is indeed at 1, 2, meaning that our solution is x equals 1. Example here, we can see that there are no intersecting points. So we have no intersecting points, meaning that we have no solutions. So we can go ahead and write that down. So no intersecting points, meaning that we have no solutions. Now, taking a look at quadratic absolute value equations, we're going to have to sketch this one out actually. So let's go ahead and first talk about what we'd actually need to do if we were to do this on our graphing calculator. So we're going to make y1 equal to the left-hand side. So I'm going to go ahead and pop in the absolute value of x squared minus 9 into y1. And then in y2, we're going to make it equal to 7. Now, of course, because I want you guys to get some drawing practice here, let's go ahead and do this by hand first. So for our absolute value function here, we know that we're going to have both a positive case and a negative case. So let's start off with a positive case. Y is equal to x squared minus 9. So this is really telling us that we just have a parabola here, and we're going to go ahead and factor it, and we end up getting x minus 3 and x plus 3. This is a difference of squares. So we can see that we're going to have an x-intercept at negative 3 and one at positive 3. We can tell that our vertex is going to be right in the middle of our x-intercepts due to symmetry. We can also use our formula x is equal to negative b over 2a. So in this case, because our b is 0, then our x is just 0 anyways. So plugging in that value of 0 into my original equation, y is equal to 0 squared minus 9. That means that our vertex is going to be at 0, negative 9. So, of course, we can't really see our vertex down here. So let's go ahead and extend this a little bit. And we'll have negative 9 somewhere down here. And we can just go ahead and plot that point. We can go ahead and plug in some other values such as x is equal to 1. So when x is equal to 1, we get y is equal to 1 squared minus 9. That gives me negative 8. So here at 1, I'd have negative 8 there. And due to symmetry, I would also have the same thing on the other side, except it would be at negative 1. Let's look at some that are going to come out here up top. So let's say, for example, we're going to look at if x is equal to negative 4. So y is equal to negative 4 squared minus 9. So that gives me 16 minus 9, and 16 minus 9 is going to be 7. So at negative 4, we have a y value of positive 7. So again, due to symmetry, we're going to do the same thing on the other side at positive 4, or when x is equal to positive 4, y is equal to 7. So we've got a couple of points that we can use here. So we can go ahead and sketch our graph through those points. So I know it's going to look a little rough here, just freehanding it, as long as we're making it through those points accurately. So let's go ahead and highlight that a little bit. And then now what we're going to do is we're going to draw the negative case. So the negative case is really just going to be everything here, but flipped. So essentially what's going to happen is we'll have negative on the outside and then x squared minus 9 on the inside, which is really just negative x squared plus 9. So essentially what happens here is, since our a value is negative, we're going to open downwards. And instead of our x-intercept being at -9, our x-intercept is now at +9. So what's happening with our graph is all of these points down underneath are going to get reflected back up here. So that -9 gets reflected up to become a +9. This -8 gets reflected to become a +8. And same thing with the +8 on this side. And what's going to happen with our x-intercepts is they'll stay exactly the same. So we know that we're going to draw our parabola through our x-intercepts. And we can take a look at these last 2 points here at +7. So the +7 gets reflected back down here to become a -7 on both sides. So let's go ahead and sketch through that as well. So taking a look at what's happening here, we can see that for our absolute value function, we need to only take the positive portion, right? So our positive portion is essentially going to be this part right here. So if we're looking at only the positive portions, it's going to be, maybe I'll do this in yellow, it's going to be this positive portion of the red, then the positive portion of the blue, and then back up for the positive portion of the red. So that in the yellow is, and maybe I'll do this. I'll do this in blue. Let's go purple actually. Y is equal to the absolute value of x squared minus 9. That's going to be in the yellow. I know it's a little bit weird. So that's going to be the graph in yellow. It's going to give us that kind of W shape that looks like this. And then what we're going to do next is I'm going to go ahead and make a line through y is equal to 7. So here y is equal to 7 is going to look like this. Let's go ahead and draw that straight line through there. And we see that we're going to have 2 intersecting points. We've got one right here at +7, another one here at +7, but we're looking at our x values. So when x is equal to -4 and when x is equal to +4. So those two should be at least 2 of our solutions. And we can see that we've got actually 2 more solutions right here. I've got one there and one there. This one's a little bit tougher to see, but we're going to go ahead and verify those graphically as well. So let's go ahead, put that into both our Casio and TI calculators. So starting off once again with our Casio, let's hit exit. Let's clear everything out of here. So let's get rid of that, get rid of that. And we end up with option number absolute value. And we'll have x squared minus 9, close bracket, and y equals 7 for our second function. And we can see that we've got 4 intersecting points, 1, 2, 3, 4. Let's hit G solve, intersect. The first one there, we get x is equal to -4. So our solutions, let's go ahead and write those down. Solutions, x is equal to -4, x is equal to, let's go ahead and press right, 1 point or -1.4. So we get -4, -1.4, or -1.41. Let's go to the nearest hundredth. We'll see that we have one more here on the right. So we get y is equal to +1.41. So x is equal to +1.41. And last but not least, we get x is equal to 4. Once again, let's go ahead, double check, and we can see that we have a 4th intersection. Now I can already hear all of my TI users groan out there because, yes, you guessed it. It's not as easy looking for 4 solutions on a TI. It just means that we're going to have to do second trace intersect 4 different times. So starting off with our y1, we said that we had x squared minus 9 in y1. And then for y2, we have y2 equals 7. So let's go ahead and graph that. And we'll see our absolute value function come down slowly. Our second red line there gives us 4 intersecting points. We're going to hit second trace. We're going to go to intersect, so number 5. And maybe I'll just do this one right over here. 1, 2, 3. And we get negative 1.41, just like we did on the Casio calculators. Now, I'm not going to do all 4 for the interest of time, but you can see that we would get the exact same result no matter what. Now, one quick thing for the Casio, what I'd recommend is, because my screen does this, I don't quite remember if the newer version of the Casios does this. Sometimes what you'll need to do is actually expand your window a little bit, meaning that we should try to expand our Y values just a little bit more this way. So I'm going to look at my window and let's go to our Y maximum. Let's expand that to perhaps 20 and let's see what that looks like. So we can see a little bit more here. So if I go G-solve, intersect, we can actually see those intersecting points. So if you find that you can't actually see anything due to these two equations up top, you can just expand your Y maximum or Y minimum, depending on what you're looking at. For these next few examples, you can go ahead and pause the video, try working through these on your calculator, and then unpause once you're done to check your work. We're going to look at solving linear absolute value equations algebraically, and there's going to be a few things that we need to keep in mind. First thing is, when we're looking at the absolute value portion here, we're going to recognize that we have 2 cases that we want to look at. First of all, we have the positive case, which is just 2x plus 4, and then we're going to have the negative case where we just put a negative in front of whatever that original function was. So what this gives us is our graph, where we'll have y is equal to 2x plus 4. So for us, that's a slope of 2 and a y-intercept of 4. This is back from math 10. And it'll look something like that. And this reflected part is basically the exact same equation, except it's now going to come down this way and intersect, or have a y-intercept of negative 4. So you can see that if we were to look at the absolute value graph itself, it would just be the resulting purple graph here. Why we wanted to plot those is so we can see that our x-intercept here is at -2. So we get x is equal to -2. And that helps us put our equation into 2 different subdomains. So we have a subdomain where x is going to be greater than or equal to -2, and where x is less than -2. So why do we need to consider that? Well, for us, remember that your absolute value function is essentially made up of a positive graph and its reflected negative graph in air quotations. So we're looking at first our positive portion here of this subdomain on the left-hand side. And then we're going to look at the positive portion here of our subdomain going towards the right. All right. So what does that mean for us? Well, first of all, let's look at our positive portion. So 2x plus 4 is our graph in the red. So I'm going to do this here on the right-hand side. So we know that we have the positive portion that gives us 2x plus 4 is just going to equal to 8. And then from here, let's subtract 4 from both sides. And so let's do that, subtract 4. And we'll end up with 2x is equal to 4. Divide both sides by 2. And we end up getting x is equal to 2. So if we're asked, is the solution in the subdomain? It definitely is, because 2 is greater than or equal to -2. We're going to do the same thing once again here on the left-hand side, except now we're going to look at the negative case, which is what we graphed here starting from the left-hand side. So we get -2x plus 4, and we know that -2x plus 4, we're going to set that equal to 8. Let's go ahead and distribute that negative to everything on the left-hand side. So we get -2x minus 4 is equal to 8. We can add 4 to both sides, so plus 4 plus 4, and we get -2x is equal to 12. Let's divide both sides by -2, and we end up getting x is equal to -6. And if we check to see if this is in the subdomain, x is less than -2, that is correct. So we can say yes. And we know that we have two solutions here. So if you don't trust yourself using that subdomain, what we're going to do is we're just going to put this number back into our equation here. So we get the absolute value of 2 times -6 plus 4 is equal to 8. We get the absolute value of -12 plus 4 is equal to 8. And we get the absolute value of -8 is equal to 8. So 8 is equal to 8. That is correct. I can do the same thing on the right-hand side here. So I can have the absolute value of 2 times 2 plus 4 is equal to 8. So inside I get the absolute value of 8 is equal to 8. So 8 is indeed equal to 8. So I can verify these algebraically just by plugging my solutions back into the original equation. Now, one thing that I do want to bring up is that there's an alternative method for solving absolute value equations. So let's go ahead and take a look. So absolute value of 2x plus 4 is equal to 8. That's also the second method that I want to bring up is one that looks like this. So knowing that we have a positive case and a negative case, some teachers like to explain it like this, where we just have our positive case being 2x plus 4 is equal to 8. Standard, nothing's changed from our previous example. Now, the only thing that does change is instead of putting the negative in front like this that we did previously, what some resources or teachers like to do instead is that they're simply going to make the right-hand side, that constant on the right-hand side, be negative. So instead of being a positive 8, like with the positive case, it now becomes the -8 in the negative case. For some of you guys, this might work out a little bit easier, but personally, I do like to have the positive and negative cases with that reflected graph because it helps me see exactly what our graphs should look like. Whereas this one, it's going to be a little bit trickier to picture. You're going to have to do a couple extra steps. Okay, so if you were to solve this, you would still get the exact same answers. You would get x is equal to 2 for this situation. And over here, we would get x is equal to -6. So nothing really changes. It's really up to you to decide which one you would rather use to solve absolute value equations. So coming back to this example here, we're going to hop right into it. Let's find out our boundaries for our subdomains. We're going to make the inside of our absolute value function equal to 0. So 3 minus x is equal to 0. So we get x is equal to 3. So we're going to have two parts here. So looking at our graph, we can see that we're going to have, again, this is why I like to go with my original method here. We're going to have two cases where we have 3 minus x, and then we're going to have a second case where we have -3 minus x. And again, we can rearrange this to make it a little easier to figure out what it's going to look like. So this is really -x plus 3. And then for this one, it's going to be the same thing as x minus 3. So here, if I were to quickly sketch out my graph, -x plus 3 means that we're going to have an y-intercept of +3. So y-intercept of +3 is going to be up here. And then it's going to have a slope of -1. So it's going to look something like this with an x-intercept of 3. So this point right there is 3. Maybe I'll do that in green. So that's going to be +3. And then now for the second portion, x minus 3, we're going to have a positive slope of 1 and a y-intercept of -3, but we still have our x-intercept of 3. So we can see here for our positive case, 3 minus x, all right, 3 minus x is actually this blue line. So for this blue line here, what's going to happen is we'll have this subdomain of x has to be less than, in this case, less than 3. Now, again, some of you guys like to just put the underline here on the positive case. It doesn't really matter, to be honest. As long as you keep it on one or the other, it's perfectly fine. So in this one, let's just keep it on this one where x is greater than or equal to. So once again, let's put this one, let's put a +3. So looking at our positive case first, we can see that we have 3 minus x is equal to 3x minus 1. We're going to go ahead and solve for x by moving the x over to the right-hand side. So I get 3 is equal to 4x minus 1. Let's add 1 to both sides. 4 is equal to 4x. Divide both sides by 4, and I get x is equal to 1. So we can see if this is in the subdomain, is x less than 3? And the answer is yes. So it should work. And once again, we can always verify that graph or algebraically. If we have the absolute value of 3 minus 1 is equal to 3 times 1 minus 1. So this is going to give us the absolute value of 2 is equal to 2. So we can see that that is correct. The absolute value of 2 is 2. So that is correct. And now let's do the same thing for our negative case. So negative 3 minus x is going to be equal to 3x minus 1. Let's go ahead and distribute. Negative 3 plus x is equal to 3x minus 1. Let's subtract x from both sides. So I get 2x minus 1. And let's add 1 to both sides. Negative 2 is equal to 2x. And dividing both sides by negative 2, I get x is equal to negative 1. So is the solution in the subdomain? Is x greater than or equal to 3? And the answer is no. So this is what we consider an extraneous solution. And if we were to go back a couple pages to this example, or to the same exact example, 3 minus x, or the absolute value of 3 minus x is equal to 3x minus 1. Let's go ahead and go back to this one. It was this page right here where we only had one intersecting point, and that was when x was equal to 1. So that matches up with whatever we had here. So once again, just because we ask you to solve something algebraically doesn't mean that you shouldn't also verify it both algebraically and graphically to check to see if you've made a mistake somewhere. So for this next one, you can go ahead and pause the video and unpause once you're done to check your work. Now that we're looking at solving quadratic absolute value equations, it's really useful to have a good idea of what you're doing visually. So what I mean by that is if we're looking at the inside here, x squared minus 9, we know we're going to have, once again, a positive case, which is just going to be x squared minus 9, and a negative case, which is going to be negative x squared minus 9 with the negative on the outside, which is really the same thing as negative x squared plus 9. So we can see that this graph and that graph are really just reflections of each other. So if I were to quickly sketch this out, we would once again have a parabola that comes all the way down here for this positive case. And then for the negative case, it'd really just be the exact same thing, but flipped. So you'd have your vertex up here and it'd come down here. So the key to understanding how to solve this is really looking for our x-intercepts. So we know that we have an x-intercept here at -3 and one at +3. How do I know that? We're going to look here at x squared minus 9 equals 0. So when x squared minus 9 is equal to 0, I can go ahead and factor that out as x plus 3, x minus 3 is equal to 0. So I have two solutions. X has to be equal to +3 and x has to be equal to -3, giving me my two x-intercepts. So for us, our absolute value function is actually just this part here. So we're going to trace this, and maybe what I'll do first is I'll highlight this in yellow, and then I want to talk about our equation here, or our graph rather. So we can see that in our two parabolas, we're going to have three sections where we have positive values or positive y values. We're going to see our two ends here. We'll see the red here and the red here. And then we'll see our blue parabola, or blue part of our parabola here in the middle, that's also positive. So we've got this section, and here in the middle. So what that tells us is that for this subdomain here, as long as we're looking at the part of the blue parabola that's greater than or equal to -3 and less than or equal to +3, we're going to have positive y values. Now, on the other hand, if we're looking at the two red ends here, we can see that x has to be greater than 3, but at the same time less than -3 for us to have positive y values. So which or when will these occur? Now, if we're looking at the red here, we were looking at our original graph, x squared minus 9. So let's go ahead and put that in this section. So x squared minus 9 has to equal to 7. Whereas on the right-hand side, we're just going to be looking at the negative portion. So negative x squared minus 9 is equal to 7. So let's solve our left-hand side first. So we have x squared is equal to 16. We're going to take the square root of both sides, so we get x is equal to plus or minus 4. Asked, is the solution in the subdomain? Is x equals -4 less than -3? That is true. And is x greater than +3 when it's +4? Yes, that is correct. Let's do the same thing here on the right-hand side. Let's distribute that negative first. And let's go ahead and subtract 9 from both sides. We can multiply both sides by -1. And we get x squared is equal to +2. And then we're going to square root both sides. We get x is equal to plus or minus square root 2. And when we're asked, is this solution in the subdomain? It absolutely is. So for our second example, we're going to, again, factor out the original here, x squared minus 2x, to find out our x-intercepts. So we end up with x times x minus 2 is equal to 0, meaning that for our original case, so if we have our positive case, which would be x squared minus 2x, and then let's make this one our negative. I know I've inverted the colors. Then we'd have negative x squared minus 2x. Let's kind of see visually what they would look like. So we know from factoring, we get two x-intercepts of x is equal to 0 and x is equal to +2. So for a quadratic equation that looks like this, x squared minus 2x, we'll end up with something that looks kind of like this. We'll have an x-intercept at 0, x-intercept at +2, so we should have it kind of look like this. And then if we were to look at this negative case, it would just be the opposite. It would come up and look kind of like that. So for us, our red portion here is going to be our ends. So we can see that we've got our subdomain where x has to be less than something and x also has to be greater than something. And when we set up this subdomain here in the middle, it's going to be that green section. So it's going to be this part right there where x has to be greater than or equal to 0 and less than or equal to +2, leaving us with x has to be less than 2 and greater than 2 for this side. So let's put our red portion into the left-hand side box. X squared minus 2x is equal to 1. And then for the right-hand side, we'll put negative x squared minus 2x is equal to +1. So solving for the red here, I can already tell we're going to need the quadratic formula. So we get x squared minus 2x minus 1 is equal to 0. We can't factor this normally. So we're going to use the quadratic formula. So plugging these values into the quadratic formula, we get x is equal to negative 2. So that's negative b plus or minus the square root of b squared. So it's going to be negative 2 squared minus 4 times 1 times -1. That's all divided by 2 times 1. So for us here, let's go ahead and scooch down a little bit. This gives us x is equal to +2 plus or minus. And then on the inside, we get 4. And that looks like we're going to have 4 plus 4 gives us 8. That's all divided by 2. We can simplify that bracket on the inside, or that radical there. So this is really the same thing as 2 plus or minus 2 square root 2 all over 2. We can divide both terms on top by 2. So this gives me 1 plus or minus square root 2 as my two solutions. So let me make that a little neater, 1 plus or minus the square root of 2. So I get two solutions. Is the solution in the subdomain? And the answer is yes. We're going to check that very shortly after we solve for the green. So for the green here, let's go ahead and distribute. We get negative x squared plus 2x is equal to 1. We get negative, let's go ahead and do this. Let's move everything to the right-hand side to make that x squared positive. So we get 0 is equal to x squared minus 2x plus 1. So once again, we're going to use the quadratic formula. We get a is equal to 1, b is equal to negative 2, and c is equal to positive 1. So let's have x is equal to negative 2 plus or minus the square root of b squared. So negative 2 squared minus 4 times a, which is 1, times c, which is also 1. So this gives me x is equal to positive 2 plus or minus. On the inside, we have negative 2 squared, which is 4, minus 4. So I have plus the square root of 0. That's all divided by 2. And I end up getting x is equal to 2 plus 0 divided by 2, which is just 1, and 2 minus 0 over 2, which is just 1. We can verify these again using our graphing calculators. Please don't be shy about doing so. It's a really good idea to get used to using a graphing calculator to help you verify your answers. Here on this page, you can pause and unpause once you've done the work so you can check your answer. Let's try one more bonus example here where we have some other stuff happening outside of your absolute value portion. So we can see here that we've got a 4 times the absolute value of 2x minus 14 plus 10 is equal to 18. The key here is just to isolate the absolute value and then solve like usual. So what I mean by that is, like I said, we're going to isolate our absolute value by subtracting 10 first. So we're just going to use reverse BEDMAS. So we'll get 4 times the absolute value of 2x. Oops, let's make that straighter. 2x minus 14 is equal to 8. Let's divide both sides by 4. And we're left with the absolute value of 2x minus 14 is equal to 2. So from here, we're going to have our positive case, and then we will have our negative case. So we'll have 2x minus 14 is equal to 2. And then for our negative case, we'll have negative 2x minus 14 is equal to 2. And from here, we're just going to solve for both sides. So we'll have 2x is equal to 16. So I get x is equal to 8 as one of my solutions. For my negative case, I have negative 2x plus 14 is equal to 2. I'll have negative 2x is equal to negative 12. So I divide both sides by negative 2, and I get x is equal to 8. And if I were to verify these really quickly by plugging them back into the original, we would see that both solutions would work. I'm going to do us one better. Let's go ahead and plug this into, maybe I'll use my TI, or rather my Casio calculator. Let's go ahead and move this guy over. Use my Casio here and double check. So we'll end up getting, let's go ahead and do this, 4 times the absolute value. Oops, let's go back. 4 times the absolute value of 2, and let's go 2 times 8. So 2 times 8 minus 14, close off that bracket, plus 10, and we end up getting 18. I do the exact same thing with 6, so I have 4 times the absolute value of 2 times 6 minus 14, and then plus 10, and that should give me 18 as well. So both my solutions worked. I've checked them algebraically. Of course, we can also graph this as well to see if that is true, and we would end up with our x values also at 8 and 6. That brings us to the end of today's video. Hopefully you learned a thing or two about solving absolute value equations, both graphically and algebraically. As always, if you have any questions or comments, feel free to leave them down below. Thanks again for watching, and I'll see you all in the next video. Thanks again for watching, and I'll see you all in the next video.